Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. When it comes to hosting services on servers for a business, they all sit in what's called a data center. Data centers are a dedicated room of a building where groups of servers that provide services like data storage and web hosting are networked together. Data centers have more than just servers though. They have networking equipment, cooling systems, fire protection systems, and they limit who can enter those rooms to a small group of people. The idea of a data center goes back a long time ago. A common movie among technology professionals is called War Games, where you can see computers and mainframes were massive in size, and they could take up a full room just on their own. Today, of course, we can find hundreds of servers in a single data center, and it's not uncommon for a business with remote locations to also have local data centers at those branch locations. Some of the earlier network technologies that you'd see in a data center include T1 or E1, OCX fiber, and frame relay. Today, you're more likely to see Ethernet, MPLS, or SD-WAN technologies. The data center architecture is what allows everything to function reliably and efficiently throughout the entire network and beyond. A small company of, say, 5 people isn't going to have an architecture much different than what you have at home right now. For example, your ISP connection, a router, a switch, and maybe a server or two. As companies grow, so do their technology needs, and that directly increases the need for a solid architecture. Now, Cisco has developed a popular 3-tiered architecture consisting of an access layer, a distribution layer, and a core layer. The access layer, or the edge layer, is the primary connection point between users and the data center. Keep in mind that in a data center, the servers are considered users for this discussion. The access layer consists of the cables and access switches that are closest to the systems. In a server rack, it's not uncommon for this switch to be installed at the top of the rack and to connect everything together inside of that rack. This is what we call top of rack switching. The distribution layer, or we also call it the aggregation layer, provides connectivity between all the different racks that you have in your data center and the core layer. The distribution switches are usually layer 3 switches or multi-layer switches, and Cisco recommends having 2 distribution switches for each access switch that you have. By having that configuration, you have some redundancy built in. The core layer connects all the distribution layer switches, and it also acts as a connection point for external connections like the internet. All these systems operate at layer 3, or the network layer of the OSI model. Since these connections have the highest speed and the highest bandwidth, we refer to this as the backbone. Again, Cisco recommends having 2 core switches to each access switch for redundancy. Traffic flows are a way of describing how data moves into or out of your network and throughout the data center. The names of the traffic flows are associated to the direction on a compass. So if you had a compass and your network diagram side by side, those are the direction names. North-south traffic describes data moving into or out of your network. Northbound traffic is leaving the network, and southbound traffic is traffic that's entering your network. And then east-west traffic is data moving between systems within the data center. There's no distinction between east or west, so it's called east-west. But I suppose based on your architecture diagram, you could be more specific with east or west. This kind of traffic can be data backups, alerts, or really anything. In a data center, you're very likely going to see mass storage devices where large amounts of data can be stored. Hard drives and solid-state drives, or SSDs, are the most modern type of mass storage device that you're going to see, but you might also see tape backups even though it's an older technology. If you were to crack open a server, it might have an M2 or an M.2 drive attached to the motherboard. If you aren't familiar with these drives, it's basically an SSD that looks like a stick of RAM, and you can even get them for your personal computer. These drives are so fast and great for installing the operating system onto. For actual data storage, storage area networks, or SANs, is a system that basically creates a large pool of mass storage devices behind the scenes, and you'll see one or several logical disks depending on how you have it configured. You have 2 main choices when it comes to supporting a SAN. The first is Fiber Channel, or FC, which is a high-performance storage ecosystem with its own cables, protocols, and switches. And then you have Internet Small Computer System Interface, or iSCSI is how you pronounce it, and it's built on top of TCP/IP, and it enables devices that support iSCSI to use existing networks. Unfortunately, since a lot of equipment and networks weren't designed to support this, performance can suffer, so you might need to use jumbo frames to reduce the total number of frames that are moving throughout the network. A SAN uses something called multipathing, where it provides more than one connection to a server to provide redundancy and high availability in case one path fails. Network attached storage devices, or NASs, are smaller devices that take a few drives and configures them into an array. One of the big differences between a SAN and a NAS, besides the amount of storage available, is that a SAN is seen as a virtual disk, which means that your computer thinks it's a physical drive. The location of a traditional data center entirely depends on the size needed and the size of the company. Small companies that have very limited server needs might just have servers or data storage devices sitting on a desk in their office. If the company grows some, they might create a mini data center in a closet or a different room than the users. After all, some of this equipment can start to get loud, especially the servers the more that you have. This is usually about the time that you need a server rack to put all this equipment into one central unit. Next, the company might need a larger space. You can build a separate building or area on premises, but there are also third-party companies that have something called co-location, meaning that you can put your servers into an existing data center with extra space. If your company gets big enough, you might even have a data center at your headquarters that provides services to branch offices. I've even seen remote or branch offices have smaller data centers that are on premises for critical servers to avoid issues if the link to the headquarters goes down. One of the key concerns with data centers as they get larger is that the center of your building is usually the best location, and they need things like cooling systems and fire suppression systems to keep things cool and put out fires if they start. What we consider the modern data center today is so different than traditional data centers that you might see still in some organizations. One of the major advances that's mainstream now is virtualization, meaning that instead of purchasing a new server for every service that you need, we can run a few or 10, 20, or even 30 virtual servers on a single piece of hardware. Software-defined networking is another major improvement, with making networks and data centers more powerful and more flexible. Don't get me wrong, you still have some physical gear, but in most cases, it gives the structure of the network, not necessarily all the functionality. The architecture we use has changed a lot too. With virtualization, you don't really need the distribution or the aggregation layer. You can implement a spine and leaf architecture where every spine switch connects to every leaf switch in the top of the rack in a two-tiered approach. This creates a mesh network. This also means that you don't need the backbone switches. High availability, or HA, is an extremely important concept for data centers. High availability at its core means to have alternate options available in case a technology or a path fails. You can easily switch over. Some of the high availability options include load balancing, where you can share the workload between two or more systems. For example, you might have traffic alternating which router it goes to. Clustering is a form of load balancing that groups equipment, like servers, together so that it appears as one to the user, but they share the workload and each one can take over if the other fails. Redundancy uses additional equipment and connection options so that if one goes down, the other can take over. The big difference in definition is that redundancy specifically focuses on something failing and something taking over the system or process, where load balancing and clustering assume that everything is working at the moment, but could fail. Common routing protocols that support high availability and redundancy for a default gateway include first hop redundancy protocols, virtual router redundancy protocols, and Cisco's proprietary protocols, hot standby router protocol, and gateway load balancing protocol. All these protocols group routers together and assign a single virtual IP address that the clients use as a default gateway, which is nice if the system fails over to another device because they can just use that same IP address. GLBP even provides full load balancing. Another key difference is that VRRP and HSRP are considered active passive high availability, which means that there's one active router at a time. Once that active router fails, then a passive router takes over. It's also common for a data center to use multiple internet service providers or ISPs in case one experiences issues. Make sure that if you do this, you have path diversity, meaning that the traffic takes different paths out of your network and not the same line. Normal facilities or buildings have certain requirements for things like power and heating and cooling. But data centers usually will have their own specific requirements to make sure that you can provide high availability and disaster recovery. Power's got to be the first consideration. Small racks might have a 20 amp dedicated circuit plugged directly into them, or in larger data centers, you'll see dedicated power transformers that the local power grid supplies. In addition to the standard power that your racks receive, you'll want an uninterruptible power supply, or a UPS, which is basically a battery backup solution. The UPS connects to a power distribution unit, or a PDU, which is a rack-mounted set of outlets for devices to use the UPS. Again, with large data centers, you'll most likely see power generators that run off petroleum or some other form of electricity in case that power goes down. The environment in the data center is another consideration. This means that we have to think about things like temperature and humidity of the room. Typically, data centers are kept cool so that everything runs efficiently. If you look at how the airflow happens in a data center, the front of the servers have what's called a cool row, meaning that the cold air is sucked in through the servers, and then the backside is called a hot row because the hot air is coming out of it, and that's how servers are disposing of that air so that they can recool. Heating, ventilation, and air conditioning, or HVAC systems, are what handles this stuff and tries to keep the room around 68 degrees Fahrenheit and about 50% humidity. Fire suppression systems are another consideration because we're dealing with electronics and fires can happen, believe it or not. There's several different types of suppression systems, but again, we're dealing with electronics, so we typically don't want to use water-based systems to extinguish any fires. In the event of emergency, we need emergency procedures that include the building layout, fire escape plans, safety and emergency exits, and emergency alert systems. Just like normal office areas, the exits need to be labeled and locked doors need to fail open, which means that the doors are going to default to open in an emergency. Think about it. If the door failed closed and locked if power went out, somebody could be trapped inside or worse. Last, you have to perform annual fire drills and exercises to make sure that people know what to do in the event of an emergency. Documentation is crucial in a lot of things that technology professionals do, whether that's documenting the safety controls that we have implemented, government regulations, or how to repair and replace pieces of equipment. It's a must. It's also not enough to document things once. You have to keep everything updated as things change or they evolve. At the very least, you have to review your documentation at least annually to make sure that everything's accurate. Let's go ahead and talk about some of the specific types of documentation categories that you need. First category is network diagrams. This means that you need floor plan diagrams that show the physical layout of everything. You have equipment in an intermediate distribution frame, or IDF, which is a network closet on a specific floor, where a rack's physically located to do specific functions. You also need rack diagrams to describe the pieces of equipment in a specific rack. This can include servicing information, like vendor contracts, or licensing information. Logical network diagrams are necessary because they show how everything connects on the network and the purpose of the equipment. Wiring diagrams are also helpful because they can show how the wiring is ran throughout the building. For example, where does a specific cable terminate on that other end? Baseline configurations are another category of documentation that you need. This includes things like software that's installed or configurations that you're using. The configurations change over time, so this has to be kept up to date. Assessments is the last category, and this refers to any kind of assessment that's done against your data center. Site surveys deal with the data center layout and space utilization, how everything is installed, future requirements, and any concerns with current performance. Audits are an assessment of your data center performed by an outside organization, and they're done with some type of law or regulation as a requirement to meet. For example, ISO 27001, ISO 27002, HIPAA, and PCI DSS are all common audits that you might be involved with. All of these generate an assessment report that shows your current state and any areas of concern or non-compliance that need to be addressed. All this information impacts future plans and investments for the data center and overall network.